power measurement in polyphase circuits. Polyphase circuit here we mean, as all of us have in our houses and everywhere, three-phase supply. This is polyphase is three-phase. So as we discussed in the last class about the process of generation of three-phase, I'll summarize it quickly. In three-phase generator we can get three-phase voltages. Say for example this is the diagram, which are 120 degrees at phase angle. R is the red phase, Y and blue. R, Y, B. Three-phase system has three voltages, which are, suppose R starts here, after 120 degree starts Y, and after 120 degree starts B phase. This is time diagram. In other words, this is omega t, and this is the value of voltages, voltage V versus omega t. You can see 120 degree phase displacement in the voltages. The same voltage can be written as, in the phasor form, VA can be written as, this is suppose I will call it as, R is A phase, R phase or A phase, Y is B, and here we call it C phase. So VA is actually voltage at phase A. That is what? Say that is equal to Vm cos of, this is here is sine wave, Vm sine of omega t, and then VV will be at after 120 degree of VA, that is Vm sine of omega t minus 120. And VC will be again at 120 degree after this, that is minus 240, or you can say plus 120. So Vm sine of omega t plus 120. This is the time, this is the waveform with respect to time. These are the three instantaneous values of voltages. We can represent them also as, you can call it as Vm angle 0. This is called Vm angle minus 120 in phasor form, and this is Vm angle plus 120. Minus 240 is same as plus 120 from the three-phase point of view. Sometimes if you want to represent in terms of RMS, you can also call it as Vm by root 2. This is RMS voltage and the Vm is peak voltage. Because many times in the phasor we use RMS values, not the peak value. This side, these three-phase voltages are represented here in this phasor diagram. As you can see here, VA is equal to, suppose I call it as Vm by root 2 can be called as V phase angle 0. This Vm by root 2 is termed as Vp. This is Vp angle 0 is the VA voltage. After 120 of VA, you can see the black line here. Vb is of Vp angle minus 120, and this third one is Vp angle plus 120. So now this is the basic phasor diagram. Phasor diagram is a very important concept. You should understand it thoroughly. How to draw phasor diagram to understand the polyphase system especially, or in general about any electrical system, phasor diagrams are important. The VA, VB, VC, these three black lines show the three-phase voltages. Now suppose our topic today is basically how to measure power in three-phase systems. So I can remove this now. This you understand from the phasor diagram. There are three voltages, VA, VB, VC. Now we can go for how to measure the power. I think I can remove this also. Now we have a three-phase load here. I'll just draw a three-phase load, which is let's say star netted load. This is A phase, this is B phase, and this is C phase. A three-phase load supplied by a three-phase source such as this, which is a balanced source, and the load is also balanced. So suppose the load value is Z angle theta. If it is balanced load, all the three values should be here. Displacement will not be 120. You should understand balanced load means all the value of magnitude as well as phase angle are the same in all three phases. So Z angle theta is for all the three phases. I'll call it as phase A, I'll call it as phase B, and then phase C. We want to measure the power of this three-phase system supplied by a balanced three-phase source. Now what do? I'll connect two wattmeters. I'm sure you have studied about 2 wattmeter method. I'll connect 2 wattmeters and I'll prove that the power is how can you find power with the help of 2 wattmeter method. So what you connect the first wattmeter here. The current coil is normally represented by a short coil and the potential coil is represented by a long coil, because ideally it is having infinite resistance and current coil is having zero resistance. So this is wattmeter number 1, above the top one. This is wattmeter number 1, W1. How do you connect it? Current coil is here and potential coil is here. Current coil is in the phase A. The current of phase A, I call it as, let's say I call the current as IA. The second wattmeter is between these two phases. The common terminal is B phase. This is wattmeter number 2, W2. Current coil and potential coil. As you can see here, the current here is IC, phase C current. Now the voltages again here, this is phase A voltage. So this voltage will be represented by, what is the voltage here? See, pay attention. The first potential coil, the voltage is, this is phase A, and this is phase B, and this is phase C. The voltage here is VAB, because potential coil voltage from between A to B. And what is the voltage here between this the second coil? Come on, anybody?
VCB.
No, it is VCB. Why do I say VCB? Because this terminal, the common terminal is taken as positive and opposite is taken as negative. Very important thing to understand. Here it is positive at the common point and there it is negative. Then this was VAB and this is VCB, not VC. What is the difference between VBC and VCB? You should note the first potential coil of the wattmeter 1, the voltage is VAB. And second coil, the voltage is VCB, not VBC, because terminal C is common terminal. This terminal is taken positive and that is opposite is taken as negative. That voltage is VCB. What is the difference between VBC and VCB? VCB is equal to minus of VBC. Now very interesting. Now let's see this in Phasor diagram. As you can see here, the angle of the load is theta. So if I in the diagram, Phasor diagram, the voltage of phase A is angle 0. So the current will be lagging by angle theta. The current IA is lagging, as you can see in the red color, is BA by angle theta. Because I have taken a balanced system, there is a property that all three voltages and currents are displaced at 120 degrees symmetrically. So I can see here IA, IB, IC are 120 degrees symmetrically placed, just as VA, VB and VC are placed symmetrically at 120 degrees. So very carefully understand this Phasor diagram. Now you can see here IA, IB, IC, because the angle is theta, that is the angle lagging. Now let's see this thing. I'll ask you a simple question. I'm sure you have studied in the first semester also, first year. What is the reading of wattmeter number 1? I'll call it as P1. What is the reading of wattmeter number 1? Anybody? How do you find the reading of wattmeter? The reading of wattmeter is, please remember for once for all, it is, you can note down, the reading of wattmeter is given as the current in the current coil, I'll call it ICC. Current in the current coil multiplied by voltage of the potential coil. Very important, because many times you don't understand. This is fundamental. Current in the current coil ICC multiplied by voltage into potential coil and multiplied by cos of phase difference. Very good. Phase difference between what?
Current and
between this voltage and this current. Phase difference between ICC and IBC. I'll call it as cos phi. Phi is the phase difference between, pay attention, voltage VPC and current ICC. The phase difference between these two is this thing. So remember the formula: wattmeter reading is equal to current in the current coil of the wattmeter multiplied by voltage of the potential coil multiplied by cos of angle between these two. Now let's see this thing. There are two wattmeters here. Now you can see this formula. I'll call the wattmeter P1 will be what then in that case? Current in the current coil is IA. Potential in the potential coil is how much? No? Yeah, correct. VAB. Potential you can see. Potential coil into cos of, who will tell me the angle? Phasor diagram. Phasor diagram will tell me what the angle difference.
Theta plus theta.
You can also do it. You see here, angle between B, see, first of all I have drawn the VA, VB, VC. Now the VAB is actually line voltage between AB. So how can you find VAB? Where VAB can be written as VA minus VB. Okay? So VA is here, VB is here. Minus this is vector sum. That means take opposite to VB. This is minus VB. VB is here, minus VB opposite to that. And VA minus VB, this sum of the two. This is this plus this vector. If VAB is equal to this, you can see the angle is plus 30. Because this angle is 120. Opposite of that, if we take the this one, VB, opposite of that, and you can find the angle will be 30 degrees. Between the phase voltage and the line voltage, the angle is 30 degrees. Because this angle is 60. Half of that is 30 degrees. Now this is 30 degrees and this is theta, as we just discussed. The current is lagging. So net angle is how much? Theta plus. Now we have the answer now. VAB, this is VB angle 0. You can find out from the law of parallelogram. This will be root 3 times. What is that? VAB will be root 3 times VB angle of 30 degrees plus. 30 degrees plus. We can also call this term as line voltage. VL angle of plus 30 degree. Remember this expression. The line voltage is leading the phase voltage by angle 30 degrees. So now this is the angle of VAB and this is the angle of IA. I just told you formula for P1. Current into voltage is how much? The voltage here is VL angle, voltage is VL. I can call the current also IA is equal to IL, say for example. Then becomes IL. IL into VL, the line current into the line voltage into cos of angle between the two. That is cos of theta plus degrees. For equation number 1, remember this. VL IL cos of theta plus 30. Now we go to the second wattmeter now. This is wattmeter reading number 1. I can know this. Wattmeter 1 will read this reading. VL IL cos of theta plus 30 degrees. Now let me ask you. Now it is your turn. Your turn. What is P2? What is P2? P2 will be what? The reading of second wattmeter. Current in the current coil is IC. And potential is VCB. Pay attention. So I just got VAB here. I just told you in 3-phase balance system, the voltages are symmetrical. So the second voltage will be after 120 of VAB. You can see VBC. AB followed by BC followed by CA. That third voltage here is the third voltage. This voltage is VCA. These three line voltages. 120 degrees displaced. But the line voltage is leading the phase voltage by 30 degrees. Now current, you can see the Phasor diagram. Similarly, IA, after IA there will be IB at 120 degree. Then after that IC at 120 degree. This Phasor diagram is showing the 3 phases. Now you can see that this is just like the voltage. This is the angle theta plus 30. What is this angle? Anybody?
Theta.
Now I want the reading, right? So the IC can be also called as IL. Current is same. Both the lines because balance volt, balance load, same current. IL current here and this is also IL. IL and IL. IL into P2 reading VCB, the voltage also is same magnitude, into VL into angle between cos of angle between VCB, remember, and IC. So you see this angle BC is here. For VCB this is very important. VCB will be opposite to this VC. Opposite to this VC. This is VCB. So if you see the angles properly, you'll find out that this angle is 30 degrees. Angle between VC and VCB is 30 degrees. Now you see this IA, IB and IC. IC angle is just seen here. IA is lagging VA by theta. IB is lagging what? VB by theta, and IC will be lagging VC by theta. This is 30, this is theta. Now you see clearly what is the angle between VCB and IC? This angle. Obviously that angle is what? Theta minus 30. Cos of theta minus 30 degrees. So you got the two readings. That's fine. That's very good. 1 and 2, equation 1 and 2, P1 and P2. Now you apply simple trigonometrical formula. We call, let's sum these two, P1 plus P2. P1 plus P2 will be what? P1 plus P2. So you understand cos A plus B and cos A minus B. So cos A plus B is what? Cos A cos B minus sin A sin B. And cos A minus B is cos A cos B plus sin A sin B. So P1 plus P2 what will cancel out? Sin will cancel out. What will remain? 2 cos A cos B. And A is theta, B is 30. So what is the answer? 2 cos of theta. Cos A is theta and B is 30. 2 cos A cos B cos of 30. All of you understand cos 30 is how much? Root 3 by 2. 2 to cancel out. What happens to this? P1 plus P, sorry, what is that? Multiplier? VL is common, right? So this is multiplied with, what's that? VL and IN. So 2 cos, this is the first, this is common term. So 2 cos A cos B and cos theta, cos 30 is equal to root 3 by 2. Cancels out, what remains? Root 3 times VL into IL. Equation number 3. VL IL. And one more thing. Sorry, here is one more term here, cos of theta. Equation number 3. Root 3 VL, we discussed earlier. What is this power? This is the P3 phase. Understand? Root 3 VL cos theta is 3 phase active power. That we get here root 3 VL. That means the two readings of the two wattmeters, if we sum them together, the answer is total 3 phase power. Now let's do this one more thing. P2 minus P1, let's do that. What is P2 minus P1? This one, again, cos A minus B, then that will be common term. Minus of cos A plus B. What will remain? Then that case, the cos term will cancel. Sin term will remain. What will happen? 2 sin A sin B will remain. So that means what? 2 times sin A is what? Sin of theta into sin of 30 into VLIL is common into VLIL, right? So what is sin of 30? 1 by 2. What remains here? That remains, what remains? VLIL into sin theta. Equation number 4. What is this power? Is this Q3 phase? No. Q3 phase is how much? Q3 phase is root 3 times, this is P3 phase, root 3 VLIL cos theta. So Q3 phase is root 3 VLIL sin theta. So what is this power? P1, P2 minus P1? This term is equivalent to, what is that? Q of 3 phase power divided by 3. Equation number 4 as I told you. So equation number 3 and 4 gives you active power and reactive power of 3 phase. 2 wattmeter is sufficient to measure both the powers, active as well as reactive. Now one last thing here. What is the power factor angle? Theta. Can you measure with the two? See the equation number 3 and 4. Can you find out the theta? We all know tan theta is equal to, what's that? Tan theta is equal to? Sin theta, that is P1 plus P1 minus that is equal to Q3 phase upon P3 phase, right? Q3 phase upon P3 phase. So So what is the tan theta? Using question number 3 and 4. What is tan theta? This is, you can see here from here. Sin theta you can see from here also. Sin theta upon cos theta is equal to tan theta. What is that now? This is P2 plus P1. This is P2 minus P1. Q is equal to, remember this thing here? What will get here? Come on, complete this equation.
P2 minus P1.
Q3 phase is equal to root 3 times P2 minus P1. So what is that here? Root 3 times P2 minus P1. And P3 phase is how much? P2 plus P1. So what is that? Its denominator is P2 plus P1. Do not forget the root 3 term. Because here root 3 was missing. So this is divided by root 3. So this is the third expression, number 5, gives you the answer for the power factor angle. Theta is equal to tan inverse. What is that? Root 3 times P2 minus P1 upon P2 plus P1. This is very important concept. The phasor diagram. You have to be very careful about drawing the phases. You can also do it from the simple expression of mathematics. You can just see 120 degree displacement. There also you can find the same thing. 3 expressions. P2 plus P1 gives you 3 phase reactive power. P2 minus P1 gives you Q3 phase upon root 3, and this gives you the power factor angle. This is the 2 watt meter method for measurement of 3 phase power. It can give you all the values, active power, reactive power as well as power factor angle. Thank you.